my name is Madhav. Today my topic is about method of transistor biasing. Coming to topic methods of transistor biasing. There are four types of transistor biasing methods are there. There are base resistor method, emitter base method, biasing with collector feedback resistor, voltage divider bias. Last one. First one, transistor biasing. The proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal is known as transistor biasing. Base resistor method. In this method, a high resistance RB several hundred k ohms is connected between the base and the positive end of supply for NPN transistor and between base and negative end of supply for PNP transistor. Here the required zero signal base current is provided by the VCC and it flows through RB. It is because no base is positive with respect to the emitter junction is forward biased. The required value of zero signal based current in and hence IC equals to beta IB can be made to be flow by selecting the proper value of base resistor RB. Circuit analysis. Then coming to the circuit analysis. It is required to find the value of RB so that required correct collector current flows in zero signal conditions. Let IC be the required zero signal collector. Circuit analysis. As VCC and IB are known as and VB can be seen from the transistor manual, therefore value of RB can be readily found from experiment. Since VB is generally quite small as compared to VCC, the former can be neglected with little error. Then it follows the experiment that RB equals to VCC by IB. It may be noted that VCC is a fixed known quantity and IB is chosen at some suitable value. Hence RB can also be found directly and for this reason this method is sometimes called fixed bias method. Stability factor. Stability factor is equals to beta plus 1 by 1 minus beta into di beta by C. In fixed bias method of biasing, IB is independent of IC, so that DIB by DIC equals to putting the value of DIB by DIC equals to 0. In above expression, we have stability factor is equals to beta plus 1. Thus, the stability factor in a fixed biasing beta plus 1. This means that IC changes beta plus 1 times as much any change in IC. If beta equals to 100, then S equals to 101. Due to large value of S in a fixed bias, it has poor thermal stability. It has poor thermal stability. Advantages. The biasing circuit is very simple as only one resistance RB is required. Biasing conditions can be easily set and the calculations are simple. There is no loading of source by the biasing circuit since no resistor is employed across the base emitter junction. And disadvantages. This method provides poor stabilization. It is because there is no means to stop a self increasing collector due to the temperature rise and individual variations. For example, if beta increases due to transistor replacement, then IC also increases by the same factor as IA is constant. The stability factor is very high, therefore there are strong chances of thermal runaway. And due to this disadvantage, this method of biasing is rarely employed. Thank you.